Good evening, everyone. Welcome to the AI simulation series in physics. And today I'm going to show you one more simulation as you see on the screen. So, this is about the police and thief series. Earlier, this was also available in the ratankar.com in my website, but it was a very miniaturized version. And then, since I learned a little bit of AI tools and how to use API keys, how to integrate them, and how to use prompt engineering, okay, using ChatGPT or vibe coding tools. So I started designing new tools. In fact, I have developed several other tools, but some of them have inherently some bugs. So I have not just published it across. So this is one of the tools that I find that it is free of bugs, but maybe if you find any one of them, you can just let me know. You can either message me or maybe you can put it in the YouTube channel itself that what went wrong, how well it was, and you can give me all the feedbacks. Okay, so this is about the police and the thief chase. So what happens is a police will be chasing a thief, and as a result of it, it will be able to catch or not is a bigger question that we have. How do we do it? Is that we take up a map. You can take up the map of your own place. Okay, it's not that okay. You always have to look into this itself. Since I am staying in Bangalore, so therefore I have to use the Bangalore map. Maybe if one of you is staying in some other place, okay, so you can choose that one. So first, let me show you where is this available. This is available in my website. Okay, I have forgot to tell you that all my creations, whatever I do, I'm going to put it into my new website, which is known as prayogashala.com. This is my third website in my website series. The first one was ratankar.com, which is my homepage, okay, which I started initially and tried to put across blogs and make people understand how it was and so on. And then the second one was ibphysicswithrao.com, and this was exclusively only for the IB students, wherein the solutions for the past papers of MCQs and as well as misconceptions in physics, all this will be discussed extensively. Then this is my third website, which is prayogashala.com. As such, it tells you that it is nothing but about finding out what are the new experiments, novel experiments that I have designed. So now this website I have not integrated with the ratankar.com anything here. The reason is because it might have several different types of applications. So one of them is physics. Maybe I will be putting affiliate marketing. I'll be doing marketing. I'll be doing business-based tools. Okay, or any other tools. Every tool, some of them could be commercial also. Okay, don't tell me, yeah, this is fellow is selling. Of course, one has to always to be an entrepreneur. So that's what I do here. Okay, so let me try it out my best to give you better value or good value, okay, to whatever products you are using it. So this is my second tool, and you will be seeing much more tools in this website. Now let me start with this. Now first, to work with this or to use this, you need to have an API key. I'll show you how to use an API key. Already I made a video earlier also. So anyway, let me show it to you once again. So let me go to Geo API FY. Okay, so geoapify.com. When I click on this, so I get this one here. Now you need to actually log into this. In fact, I have already created a login credentials. So otherwise, you need to sign up in this. You will get a sign up button there. So when you go here, so finally you will be able to get something like this, and you have to click on add a new project here. So only then you will be able to do. So you click on this add a new project like this. It will ask for a new project over here. Let us say, for example, I am giving some name here. So let us say this is police chase, POL. I'll give something like this, and I will click on OK here. So as a result of it, I would have got one key over here. So you see, this is a key that you get here. You can click on this key and copy this one here. Right, I have copied this, copy to keyboard. So once I do this, let me go back to this here. Right, I go here and I will type here. It's been typed. Save and start. Right, now once I save and start, I'm getting something like this over here. Now since the default location is Bangalore, so what I will do is I will type some other location. I don't want to use this one here. Right, okay, now it is Bangalore. So what I will do is I don't want Bangalore. Let me choose something else. Let me say, for example, I'll type it as Chennai. I type it as Chennai and then click on the search button. So when I do this, it shows this is a place. So click on this once again, the label. So when you click on this, the map gets updated, and as you see, you get the Chennai map over here. Okay, so we are going to find out the effect of velocities and accelerations as a physics part, okay, on the thief and the police chasing. Okay, so now what I do is, let me assume that the police or the thief has started from here. Let me choose some place over here. Let me choose a place like Chetpet. Let me choose from Chetpet. I've gone to this place earlier also, and from here, let me say he runs all the way along to Parktown. Parktown is nearby. Okay, Parktown, or maybe Georgetown. Okay, I'll click here. This is a destination, right? So this I have done, and as you see, the red and the flag has been going over here. This is the start, and this is the stop over here, and you can see nearby to this Chetpet is the police station over here. Okay, this is the police station where the police has been located, or the police jeep will start from here. Now let us go here. Thief velocity is 15 meter per second. You can actually change this. Police velocity is 20 meter per second. I would like to increase this, or maybe let me keep it as 20. Then thief curve deceleration. Whenever there is a curve, because he has to go in the same road, I am not going to put any other new road. So thief curve deceleration is -5. And the thief post curve acceleration. See, when he is going towards a curve, he has to slow down. When he goes away from the curve, that is, when he has crossed the curve, then he will be moving at a much higher speed or higher acceleration. So I have taken this. Police curve deceleration is -7. So I'll do one thing. I'll just change this value, because in this case, definitely the police will never be able to catch the thief. So since that is -5, I will make it only -3 over here. -3. Police post curve acceleration is 5. And max velocity threshold is 60 for both of them. Then police response delay, which means that the moment thief starts, police will not start immediately. So it will take some time. So I just given this as 3 seconds. And then animation smoothness, I run this as 30 frames per second. You can change it depending upon the speed of your processor or whatever you want to do. And trailing length, I have given as 20 over here. And then I'll click on this start realistic animation. You see, we have started. After 3 seconds, this has become active. Now you see this also starts moving. Probably, okay, so it's already caught him. I think so. Now he has taken a U-turn. Oh my god. So by the time this police takes a U-turn, which is far away here, he has to come to this. Okay, it's here only. Okay, and then he has to grab this fellow. He has to catch this fellow. I think he will be able to catch, because my velocity is much higher as compared to this. Oh, he catches. Let me wait for it and see. Okay, how does he catch it or not? I'll make it a little bit zoomed in, but I'm able to see it correctly. So what were the speeds? Speeds of the police was 20 and thief was 15, and he will be able to catch it at some point. Now he is moving faster. There may be some glitches here and there. Okay, so I think so the curve, he has to slow down. He is not leaving him to go further. So some sort of programming glitches I have made it purposefully. Though the two icons are seen to be overlapping, but I want the police van to be overtaking him. And if the police van is in the front and this is the back, then I assume that he is able to catch him. Distance is too high. I have put a random variable over there to see to it that when the thief is about to catch him, so he is able to escape from them. So sometimes the acceleration increases, and that's what I have done here. And as you see, the distance between the police and the thief is now reducing. So it has almost come to 19, 18, 20. Sometimes it is increasing, depends upon the curves that we have. Even if there's a small curve, what you can see here, the map appears to be straight, but there could be a small curve over here. So even then there's a deceleration and an acceleration continuously. And that is why these differences are being seen. Okay, let us see how much does it go further. It's closer to reality, but visuals are good, but I need to change something, I think. So if you find out any more bugs like this, so do let me know. definitely I would like to change this, or maybe you can now ask the question: under what conditions will the police actually catch the thief? So since I had inserted a random number variable over there, so I think that makes all the difference, and as a result of it, so even though I had given something very strictly over here, it's not following the same thing, so it is changing across here. So hope you like this simulation, and if you find anything abnormal or not going accordingly, then definitely you can know. So now you see it says police successfully blocked the thief's path. You go here. So maybe it has taken it was supposed to take a U-turn and so on, and so it has blocked it across. Okay, and if you want to know what are the locations where it has passed through, you can just download this file. So it's here. Click on this. Now this is what it tells you. So it started at Mukta Garden, Anna Nagar, then Mayor Ramanathan Road, and it kept on going, Rayapuram, Anna Nagar, and all this. So every location, at what time it was here, how was it changing, what were the respective latitude, longitude, how was it changing, and so on. And every detail about it is given over here. And what was the, so see, you see, so here it is normal, somewhere it is acceleration initially, wherever there is a curve or an incoming curve or an outgoing curve and so on, that is it. When you're approaching a curve or moving away from the curve, so you can see the acceleration and deceleration, you see. So this has been constantly changing over here, and that's what you can observe. And the distance from the between these two, so that's also been seen over here. So this gives you distance in meters, and yeah, so see police jeep actually had several times the acceleration and deceleration over here, right? Okay, so these are all because of the random variations. You see there's a normal over here, but there's an acceleration deceleration over here. Okay, so these are all random variations that I have put across in the code. So as a result of this, okay, so there's a lot of changes over here. Hope you like this, and if you have any more queries, you can get back to me. You can write back to me in my YouTube channel. So first time I'm trying to put across something like this. Finally, you reach here. Okay, thank you for being with me. Do like, share, and subscribe to my channel so that I get more updates, and I also get better encouragement from you. Thank you.